So this is 129S. I'm securing web applications. And what I'm planning to do is cover the first part of the next chapter and then demonstrate the next project, which is command injection. And I'll just do the same thing next week, finish this chapter and demonstrate the next project, which is SQL injection, and that'll get us on the road. And XUEW, SUI perhaps? Yeah, that's fine. I see that. Yep, fair enough. Hope you get better. All right, so let's just go to chapter 3 and look at some of this stuff. Oh, by the way, if anybody's here to add or anything, I'll take care of that after the lecture. We'll have a break, and I'll just check and see if anybody has administrative issues like adding or anything like that. So here's basics of the web interface. Do we need to use Kali Linux for this? I think not in this class. There's a couple optional projects, like one I'll mention tonight, where you could do it if you have Linux, but you're not required to use a Linux install for anything in this class, I think. In fact, most of it you're going to use the Web Security Academy, and Burp is all you need. All right, so the web works by HTTP, and HTTP is, as I mentioned last time, a connectionless protocol, so it sends a request to the server, and the server sends a response, and it doesn't form a session or remember who you are. See, I see a question here, but a question with many flags. In fact, I'm glad you brought this up, and let me go aside to mention this right away. This class is unlike my others. The only projects where you actually have to send up screenshots are going to be these three, 102, 103, and 100, and Velociraptor. So I should probably rewrite this for this class, because it turns out that this project has its own scoreboard, and this project has its own scoreboard, and there will be tons of these. W600, anyway, you should turn in this image. But after that, you'll be using the Web Security Academy that has its own scoreboard. So let me make a note. I'm going to rewrite that description at the top and make it more clear, because you really aren't going to be sending in very many screenshots in this class at all. Let me figure out how to, I guess I can put it here. Okay, fix instructions. All right. Yes, well, that's another issue. Yeah. For Canvas, the best thing to do for Canvas is send up, when you are turning in something, which would be just for these projects here, send in a screenshot and the flag. Put the flag in the text. That's the best thing to do. Then we can look at the screenshot to try to figure out what's going on. Yeah, good. All right. Anyway, so here, HTTP, you send a request to the server, you get a response. Now, as we were saying last time, HTTPS improves the security of HTTP. It improves it two ways. It identifies the server, so you know you're talking to the right server, and it encrypts your data, so only that server can see the data. So that prevents some attacks, but it doesn't prevent all attacks. That's why it's not a security blanket that means you're 100% secure. It just stops some attacks, like somebody sniffing your packets with Wireshark. Now they'll get encrypted stuff they can't read. But it wouldn't stop attacks that involve fooling the server once the data gets there, like SQL injection and cross-site scripting. So here's an HTTP request, and in fact, you're going to be using it all the time. So let me just bring up Burp. We'll talk more about Burp later, but I might as well get it started now. All right. All right, so here's Burp. Burp is the main thing you're going to use in this class. And the main thing you do to get Burp started is go to Proxy and turn off Intercept. Intercept blocks network traffic, and that's not the way you usually want it to be. And then open Browser. And that will launch a Chromium browser here. And now you can surf somewhere on the internet. Like I'll go to my page. All right, so there's my page. And here's Burp. And if you go to HTTP history, you can see the requests that loaded my page. And it takes a lot of requests to load a page these days, even a very simple page like mine. But if you go to the start of it all, here's the first request that loaded my page. So if you click on that, Burp will show you what was done to load that page. And that's all. So here's the request. The request is just this plain text. So every HTTP request starts with a verb. The verb is get. This is the most common request to load a page is get. To do something like log in, the most common verb is post. Then it has the name of the thing you want to get. The slash means load the default page for this website. And HTTP version 1.1, which is what we're almost all using now. And then it tells you about host name, which is the domain name of the server you're trying to connect to. And then other information here. A cookie and some other parameters here that don't matter all that much. So once you get a request, you get a response. The first thing it does is tell you that it's status 200, which is okay, which means it understood your request, and here it is providing you with what you asked for. Then other information like the type of server being used and the date. And then after that header information is the HTML that makes the page. And the HTML will now contain image tags and other things that cause other requests to be made to load things. So that's basic HTTP. We're on one. Yes, this is, well, notice, by the way, I'm glad you brought that up. I sent a request with 1.1, but it replied with version 2. And HTTP 2 is now out. Google uses it. And apparently the Cloudflare proxy now uses it. And people are talking about HTTP 3. But yeah, almost everything is still 1.1. Just like almost everything is still IP version 4. This is a very common thing in technology and security, that you have some old thing that's not very good, but it's good enough, and so nobody moves. So anyway, you start with the verb. This is get. And by the way, there's something called referrer. Here it is, spelled wrong. It's in the actual standard, which is the page you came from. If you clicked on another page to get there, which I didn't. I typed in the URL directly. But there will be a referrer here. This is like the caller ID on a phone call. It is not, or the from address in an email. All these are there for convenience, but you can't trust any of them. They could all be faked, and there'd be no consequence. That's why people perform swatting, where they call the police and say, I've got a gun, I'm killing people in here, and they change the caller ID to point to somebody else, and then the cops will go there and raid that house and get that person in trouble. So you have a cookie. Here's an example cookie being sent up. Cookie contains a bunch of other parameters. This one has seg version and GRV insights and so on. Various cookie values are just set by the designer of the website, however many cookies they want. That was the Netscape invention, the magic cookie, which makes it possible to remember who you are. So your request is tagged with a value, and I can look at that value and decide to show you a different page than I show other people. And now we can have web services like webmail, where you log in, and then I give you a cookie, and you make requests containing the cookie, and I know whose email to show you. And so here's the response. The first line has a status code, which should be 200 if it worked. Otherwise, it's going to be 300 or 400. And then the response. The server will tell you information about the server, but this one here is the default, so it tells me it's Apache and the exact version and the operating system underneath it. That is what happens with default installs of Apache. It is not considered a good security practice. It's considered better to change it to something generic because you don't really need to advertise to attackers what version you're using. And you can have the set cookie header to set a cookie on the client. Yes, this is a banner people grab. This is the HTTP banner. There are other banners people grab like FTP and such. Yeah, most services have banners. And that's the easiest way to tell what version of software they're using, although the banners can be modified to lie to you, and that is considered a good security practice. So Pragma is a no cache. This tells the browser to not cache this page. If you don't tell it not to cache the page, it may store a local copy. And although if you're delivering pages over HTTPS, which almost everybody is these days, it's not supposed to put it in the cache. And you can take expires and tell it when the cached copy of this page would would expire. And if you set it to a date in the past, like 2009, then it'll ensure that this content is all freshly loaded. So it does not show you old images in the cache. It goes and makes a new request to get fresh images. So after all the header, this is the body, and that's going to contain data of whatever type you told it to contain. And in this case, it is JavaScript. So it's got this stuff, jQuery, and parentheses and parameters. When I did it live with Burp, I got HTML. So content type is text HTML. And so that's why I see down here HTML and head and script and all that jazz. Yeah, and there's a whole bunch of different content types you can receive. The most common, though, is HTML. So get retrieves things like images and HTML web pages, and you can send parameters in the query string, and you can bookmark the whole URL. And that might appear in server logs and referrer headers on the screen, so it is considered a really bad idea to put anything sensitive like a password in the query string. The query string is what you see right up here. There's samsclass.info, and I could put parameters here like question q equals flippy. And if I do that, my server is not expecting a parameter, so it won't have any effect, but you'll often see a bunch of parameters here, especially when I go to news articles. You'll have a whole bunch of parameters there. And those are associated with the URL and stored in unsafe places like server logs and favorites. So if you want to send something like username and password, you should not be putting it up there. It will work unless people have carefully written their web software not to accept data that comes in that way, but it's not a good practice. What you should use is a post request. Yeah, the address bar is above the window. Yeah. Oh, the address bar is above the one I'm projecting. Oh, is it? Ah, thank you for telling me. Good. There. Good. So there's the address bar. And let me refresh my Twitch. My Twitch keeps getting blurry on me. I think something's wrong with my network connection today. Good. Thank you for telling me. So there it is. That's the parameter, the part that goes after the domain name in the URL with a question mark. You can put in parameters. Good. All right. So post is what you should use instead. When you're logging in or sending up data from a form with credit card numbers and addresses or anything, you use post. So post, if you try to go back in your browser after performing a post, it will warn you that in order to resend a post request, it has to resend video. Now, my Twitch failed again. Yeah, my Twitch seems to be giving me some trouble today. Let me pause for a minute and see if I can figure out how to change my upstream bandwidth. Output. Yeah, I can slow down the maximum bit rate. And let me try that. Let's try 1500. Because I think that's worked in the past. There. Let's see if this makes it more stable. Okay. I think it means it's not refreshing the video as often, but maybe it won't crash. So let me know in the chat if it looks any better. Mine looks better now. But let's see, it might just be I'm lucky for a while. Anyway, that's post. Post sends a request with data in it. And if you resend a post, you resend the data, so you might perform the action a second time, like buying a product a second time. Bad reception, internet get cut off. Oh, so that means, I guess that means you can't hear me? Is that what that means? And let me try adjusting it again then. Maybe I went too drastic. Let's try, it looks bad. Okay, thank you for telling me. Good. Let's go to 2000 and see if that's any better. This parameter seems to help. All right. Let's see. Change the slide and see what happens. You can hear, but the video is stuck. Yeah, I'm hoping it will catch up. All right, I'm going to try. You can hear me anyway. That's good. It looks okay, but it keeps cutting in and out. Yeah, that's not good. Okay, I'm going to stop the stream and restart it, and we'll see if that helps. So I'll be back in a minute. internet is plenty fast. I see a button in the bottom of OBS that keeps changing from red to green. I think we've got a problem with Twitch. I can see it from here. Twitch doesn't seem to be accepting. I don't think it's me, because as you see, I ran a speed test here. All right, let's try moving to Zoom.